Hey everyone, welcome to the Weekly Space Hangout for Friday, just before Halloween 2015. I'm Fraser, Cain, publisher of Universe Today, and this lot of planetary stories. We're going to be talking about Go Home, a fly-through of Enceladus plumes, upcoming better imagery of new images of Kerberos, a meteor swarm, and a Halloween asteroid, and a very special guest. But we'll get to that at the end. So, joining me this week, hey Sandy.
Hi. Hi. Sorry, the internet here is terrible. I think someone is, I don't know, downloading all of High-Rise.
No, that's actually Fraser's internet is terrible today, but we love him anyways.
Yeah. Turn off Google Drive and turn off Dropbox. Yeah.
You can have my. We can look at my Hayabusa 2 sticker on my water bottle.
They have the cutest face. I really do.
So cute.
We've got Dave Dickinson. Hey, David.
Hey, officially homeless now in West Palm Beach.
And your internet is, or your connection is gonna be a little spotty because you're like doing some kind of Frankenstein's connection here, right?
Yeah, well, I said we're traveling now, so I'm attempting to use the wife's phone to kind of tether to the internet. So we'll see how it ends on.
All right. Well, we may get to you early, and that way, if it just gets too unstable, you can ditch out if you need to.
Okay.
We got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser. The scariest thing about Halloween might be David's cell phone bill.
That's why. That's exactly right. We want to let him go early so that he doesn't chew up his cell phone bill. We got Dr. Pamela Gay.
Hey, Fraser.
Dr. Paul M. Sutter. Paul.
Hey, what's up?
And our special guest this week is Yoav Landsman. Welcome, Yoav.
Hi, everyone.
So, for anyone who has no idea who you are, why don't you give us the big update? Yoav, who are you and what do you do?
Oh, okay. My name is Yoav Landsman. I live in Israel. And I'm the principal systems engineer in Team SpaceIL, which is a competitor at the GLXP, Google Lunar X Prize competition. It's a competition for private-funded spacecraft to be landed on the surface of the moon. We also need to take videos and capture images of the moon once we land there, and then move the spacecraft to another location, at least 500 meters from the landing site, take some more pictures, and transmit them back to Earth. The first team who does that can get the prize of $20 million, I suppose. But SpaceIL is a non-profit organization, so our prize, if we get it, is for donation for educational purposes in Israel of technology and engineering and sciences. And that's about it, I think, in a nutshell.
That's great. And so, for anyone who hasn't seen, updates from your group, what does your mission look like?
Okay, we are the first team out of 16 teams that bought a launch. We have a contract with a launch company. We are going to be launched in about 2 years aboard the Falcon 9 launcher. And we are the only, and the first and only group who did that.
And so the actual rover, what is your strategy for how your rover is going to operate?
Okay, the fact is that we don't have a rover. Our solution is to use the entire spacecraft and its propulsion system to hop to the next landing site. I can show you a picture, an image of this. This is the spacecraft. You can see this?
Yes.
Okay. This is you can see this. This is the spacecraft, and we are going to land the entire spacecraft. It doesn't have an orbiter or some other separate parts. So the complete spacecraft is going to travel to the moon and then land there, and afterwards do the hop.
And how many hops do you think it's going to take to actually get to the distance? Because the rules specifically is how lunar surface, and then you have to travel across the lunar surface.
I didn't hear the entire question.
So let me clarify that. So he's asking about how you're going to make it because of the rules, and I'll clarify. The rules are you have to go 500 meters by any means you want. You can flit, fly, dig, burrow, dance, whatever. You just have to get from A to B, and B has to be 500 meters away.
We can use. So our solution is the hop is the simplest solution. We don't have to develop an entire vehicle, and we just use the same spacecraft.
And so, are there any other additional parts to the challenge as well? Like, are there bonuses that you guys can do?
There are some bonus prizes. For example, if we survive the lunar night, which is a 2 weeks night, we can. There are bonus prizes for images of the heritage sites, the Apollo sites, and if we can find water on the moon, I think. We are not planning for any of this. We are focusing on the main mission. That's enough challenge. And this is it. This is what we're going to do. It's very challenging. And so the fact that other groups, other governments did that was because they have tremendous budgets. We don't have that. We have to be private funded.
And Morgan, I know you've got a question.
Yeah, I actually have a couple of questions, and the first was right about that with respect to the budgets. We know it costs hundreds of millions of dollars for NASA to leave Earth orbit and go anywhere. Can you talk about the amount of money that it's going to cost or already has cost to develop your lander?
Our full program is going to be some tens of millions of dollars.
And that's not including the cost of the Falcon 9 rocket.
That's including everything.
Everything is tens of millions. Wow.
We are not launching alone. Okay, we are a small payload, and the Falcon 9 can lift very big payloads. So we are sharing the ride with a couple of dozens of other spacecrafts. We are going to be the largest one, and we are the mass of our spacecraft fully fueled is about 500 kilograms.
That's pretty substantial. Are there any limitations on where you can land on the moon? You know, it would be bad if you plopped down right on top of, the Apollo 11 lander or something. Are there any rules saying you can't go within, 100 kilometers of this place or this place?
Do you mean? Okay, nobody can actually forbid us from landing anywhere. But first of all, we are going to land on the closer side of the moon, obviously.
Right.
Because of communications, mainly. And if we land too close to the poles, it will be too cold. And if we land in the dark, it will be too cold. So it's a combination of the site and the phase of the moon at the time of the landing, and we will probably avoid the Apollo sites because we don't want to be responsible for international you know, it will be fun to capture an image of the Apollo sites, but it's a bit risky.
So you could both prove that we landed on the moon back in the 60s as to win the new Lunar X Prize. That would be great.
Yeah.
So if everything goes well, then when will your launch happen, and then will your landing probably happen?
The launch will be in the second half of 2017. It's about 2 years from now. And what was the other part of the question?
How long after
the
that?
launch happened in 20. Yeah, how many days will it take to sort of complete to win?
Yeah. So we can do the whole mission in a few weeks, but because we are not the only payloads on the Falcon 9, then we are not necessarily be able to get the specific date we want to. We have to share. It's like hitchhiking. So it can be up to 3-4 months tops, because we have to wait for the moon to be at the right spot in its orbit, and after that we need to have the exact phase, because on the landing site we want it to be dawn. So the sun is low and it's not hot enough. It's hot.
The Apollo missions had those same constraints too. They had to land on the near side, near the equator, and right sun angle and everything. So
yeah, it's very logical.
Yeah. So is it possible that any of your competitors could be riding on the same rocket, and therefore it really would come down to a matter of hours or minutes to see who ultimately comes out victorious?
It can be. It will be very interesting if it will.
So what is the biggest technical challenge then of doing this mission for you?
The biggest.
Yeah, the hardest.
It's full of
part.
challenges.
Any of them. Go ahead and describe them all. But
okay.
I'd love to know troubling.
A big challenge is the power budget. We need to balance the budget. We need to have enough electricity, which we produce from solar panel, and especially when we will be orbiting the moon, we will have about half of the orbit in the dark. So we have to maintain the entire operation of the spacecraft, and also recharge the battery in about 1 hour. It's very challenging. Another big challenge is the landing itself. It had to be fully autonomous. We don't have a pilot to figure out problems during the landing, and we have to have a landing gears that are strong enough to absorb the shock of the landing. There are a lot of questions, a lot of things that we haven't solved to the details yet, but we have the whole solution, because without that we couldn't even buy a launch.
That's really interesting. How do you like the competitive field? Which other team are you most nervous and respectful of?
Well, I respect all of them. They all have very good engineers, very good people, and we can see their effort. We have Astrobotics, we have Moon Express. There are a couple of more who are at the first 5 groups, I think. But for us, actually, it's only a small part of the deal. It's fun to be a part of a competition, but we said from the start that even if tomorrow another group lands on the moon, we continue with our effort, because we plan to do some great achievement for Israel and for the Israeli children and youth, because we want to have them choose engineering and science and technology when they go to school and to the universities. And this is actually our main target.
Are there a lot of I mean, this is a really interesting direction that you're going. Are there a lot of opportunities in space flight and aeronautics and engineering and stuff in Israel, or is there a bit of a brain drain where people leave Israel and have to come to the United States or go to Europe to actually do this work?
That's a very good question, and actually we can't just go to work with NASA if we like, because it's a governmental administration. Israel already has a space industry. Currently we have, I think, 10 or maybe 11 operational satellites in orbit. It's much more than people are aware of. And it's very much for a country in our size.
But are there so there is like a lot of work?
Yes,
actually, want to go into this field.
I've been working for more than 10 years in the Israeli aerospace industries. I work in developing and operating the commercial communication satellites, the Amos satellites. You may have heard of Amos 6 a few weeks ago, because Facebook bought some transponders on this satellite. So we have a space community and space industry for a few decades.
That's terrific. And so also, what do you see as the future? I mean, if you as a public group can get a lander to the moon and other people are going to be doing the same thing, how do you see the future of space exploration? Do you think that this prize is really going to help move things to the next level the way that I know the Google team that sponsored the prize was hoping?
I suppose that it will, because most of the groups, maybe all of them, are planning for something commercial. They're working on business plans. So there are opportunities, and for example, it's not have to be just the moon, because for example, we just had a talk about this in work a few days ago. Our spacecraft, because we have so much fuel in it, because we need to get to the moon. Launchers don't get to the moon right now. So we need to get to the moon and for the landing. So if we decide not to land on the moon, we can actually do a flyby or even an orbit around Mars.
That's cool.
That's very cool.
That's really cool.
It means that privately funded organization can do things even farther away than the moon.
Wow. So like that same platform could go to Mars as well, if it was on a different launcher and
it's only
cleaned off a little better.
theoretical, because our fuel budget can do that. But going to Mars is another. You need to be much more time in space, and the radiation may cost you more, and the communication problems. It's not simple as going to the moon. Simple, right?
Yeah.
But it's not a great leap beyond that. If you can do that, you can go to Mars as well.
That's absolutely fantastic. And so, if you do win the Lunar X Prize, what do you think will be next for your team then? What will do you think you would go to Mars? Do you think a private lander in some other place?
I don't know. Going to Mars will be well, for me it's a dream. I don't know yet. It's going to be very fun thinking about it. We'll see.
Yeah.
On behalf of planetary scientists everywhere, I'd like to suggest Uranus.
Yep, Uranus or Europa, a lander on Europa. Have you I don't know, if you play Kerbal Space Program, you could probably, figure it out. You could try a bunch of missions with your spacecraft. Has anyone tried to create it in Kerbal Space Program yet?
I haven't seen yet. We use professional programs right now, STK, for example, which is quite the same, but with more numbers.
Right, that's awesome. So we're going to switch over to the rest of the news right now. But if people want to find out more about the project, where can they go?
First of all, we have a site. You can just Google SpaceIL, and you will get to our site. There's an English site. But that's basically it. And we are doing a lot of PR activities. There's also a blog at the GLXP site, and the shows that Pamela hosts.
So check out
Fantastic.
the Google Lunar X Prize team hangouts, which run every third Tuesday of the month.
Awesome. Well, good luck. It's great to have a member of the WSH crew also be a guest on the Weekly Space Hangout. So it's great to have you on this side of the camera this week. So let's move on to some of the other stories. And I know you're going to stick around and talk about some of the stuff. So let's move on. So first, let's talk about. Actually, you know what? We'll give Dave Dickinson a chance to minimize his cell phone bill if he needs to, and let's talk about this upcoming meteor storm.
I gotta say, Fraser, that's okay. We just sold our house, so we have plenty of money now. So we have quite a few meteor showers that have been going on. The Orionids just peaked earlier this week, and I was out watching them. They had a pretty good zenithal hourly rate, about 20 or 30 per hour or so, and they come from Halley's Comet. But something that's interesting happening this year beyond the annual showers is coming up this weekend into early November. It's called the Northern Torrids, and this meteor shower has gotten the name over the past few years as the Halloween Fireballs. Now, it's interesting that this shower doesn't have a high zenithal hourly rate like, say, a meteor storm like the Leonids did back, say, in 98 and 99. I saw the Leonids from Kuwait, from the desert in 99, and we had a zenithal hourly rate then of about 1,000 per hour. That was very impressive. Matter of fact, we're midway between Leonid showers now.
That was the craziest meteor storm ever. I loved it.
That was very awesome, and I was glad I got to see it out in the deserts from a really dark sky site. This shower, the Northern Torrids, is interesting in that it has a low rate of about 5 to 10 per hour, but it produces those meteors that it does produce. It produces a lot of fireballs, and these are the kind of fireballs that you see from dash cams and security cams, and the kind that make go viral on the internet right around this time of year. And the shower seems to have a low peak every 10 years or so. 2005 was pretty decent. I've seen a few Northern Torrids already, and I'm in light polluted West Palm Beach here in Florida right now, and the moon was full this week too. So what's kind of cool with the Northern Torrids is the moon really doesn't play a factor because they're mostly fireballs. And another thing that's kind of interesting, these and the Southern Torrids, another minor shower that are peaking right now, they come from Comet Encke. And the path of these showers in the gradient is actually catching up to the Earth from behind. So instead of having to wait till the early morning where you're rushing headlong into the meteor shower and getting all the streams of meteors, you can see these ones right before midnight as well. Matter of fact, the one I saw the other night that was pretty bright, about negative second magnitude, I would say, was about 8 p.m. And that was just after sunset here. So these are the kind of meteors that you don't really need to spend. It just needs to be dark to see them. And this shower peaks once every 10 years. And it's unique. Like I said, it's gotten that kind of nickname around the internet as the Halloween Fireballs right now. So, they call it a meteor swarm, but the article I wrote for Universe Today, there's no real hard, fast definition as opposed, I guess, to differentiate it from a storm, which we usually think of as being a zenithal hourly rate of maybe 500 or higher. This is just kind of a term that's kind of popped up in a lot of different articles for the Torrid fireballs. But it's kind of an interesting shower, and I think we're going to see some activity here peaking over this weekend.
Great. So people should keep an eye on it over the weekend, maybe while they're out trick-or-treating with their kids. Just look to the sky and see if you can see some meteors head over.
Definitely.
All right. So Sandy, if a person is also keeping their eye to the sky, what else should they be looking for?
I think we just put a link in the chat. So there's an object that came by. Everyone's calling it the Halloween asteroid. It's
great pumpkin too.
A great pumpkin. It kind of looks like a skull actually. There we go. There's the animation. And so this is asteroid 2015 TB145. Some people are calling it the spooky asteroid. Some people are calling it the great pumpkin asteroid. Some people are calling it the Halloween asteroid. This is the closest this object will get in the next 500 years. Which I think is sort of exciting. It's the Great Pumpkin asteroid, Charlie Brown. So the Arecibo and Goldstone Observatory, as well as the VLBA, as well as Rehnberg telescope, have been involved in observing it. And because this asteroid is so close, it's only 1.5 lunar distances away. I forget how many seconds the round trip travel time is. Arecibo is limited because it takes 8 seconds to switch from transmit to receive to do radar on an object like this, and I think there's something similar for Goldstone. So really the only way to observe these asteroids that are really close to Earth is to transmit from one radar station and then receive radio waves at another one. So Arecibo received for a while this morning, and also the Green Bank telescope, and then the VLBA picked up signal from Arecibo. And the VLBA is the Very Long Baseline Array. There are antennas throughout New Mexico, Arizona, Texas, and I think maybe a couple other places. And so the reason that you would use an array of telescopes, to receive signal that you transmit to this asteroid, is that you can you can track without breaking up your signal. You can track features on the asteroid and see how it rotates and get a sense of how it rotates. And from that, you can learn about its spin state, whether it's been affected by thermal torques from the sunlight bouncing off of it can actually change its rotation rate or its orbit, and so it's important to know those things. So this has been a really cool object. I don't know quite how big it is, but it's super exciting. Everyone's really stoked to get images of it. The press release from JPL said this is the Halloween asteroid, a treat for radar astronomers. So good job who's ever handling your press releases at JPL this week. So it's about 400 meters in size, so it's a little bigger than the Arecibo radar dish. It's bigger than the stadium here at the University of Arizona.
Now, it was a bit of a surprise. Right?
Sorry?
It was it's a fairly newly discovered object, right? Like it was not
it was pretty freshly discovered. So what happens with these objects is that you write an urgent proposal at Arecibo to the director, and then at Goldstone there's a Air Force general you have to communicate, Army general you have to communicate with, and so they get permission to pretty much boot everyone else out of the observing schedule and observe these objects because they are so interesting and pretty infrequent that something like this comes so close. 1.5 lunar distances, that's 1.5 times the distance of the moon. That's pretty close by, which is sort of exciting.
That's great. People wonder how objects this big and that come this close can be such a surprise. How can we not know that it was coming?
Well, we knew it was coming from, I guess, a couple weeks ago, but sure. It was probably behind the sun. It might have come out from behind the sun because we're observing this really early in the morning, and it's just sometimes it's also a really elongated orbit, it looks like, so it's just sort of hard to sometimes detect these things ahead of time. And as a 400-meter object, it really would have ruined your day had it hit Earth, but we usually detect these things ahead of time. We've discovered pretty much everything that's over a kilometer, definitely most everything that's over 5 kilometers or 10 kilometers. 10-kilometer asteroid, we call those dino killers because we think that it was a 10-kilometer asteroid that did in the dinosaurs 65 million years ago.
Have you found everything that's the size of Texas?
Everything the size of Texas is Ceres.
Okay.
So if there was a bonus asteroid coming to hit Earth the size of Texas, we would have problems.
Best response ever.
Yeah. And Yoav, could your lander land on this asteroid? What do you think?
It would probably sink up to its waist.
Would it be a very soft surface?
It's probably a very soft surface. I'm guessing these things are generally rubble piles, or in polite company we tend to call them gravitational aggregates. So they're just a bunch of gravel stuck together with van der Waals forces. So if you landed on it, you would probably sink up to your waist in gravel, and then if your astronaut buddies and your spacecraft plucked you out, you'd be covered in little bits of gravel stuck to you, and you'd be really sad because getting it all off before you got through the airlock would just really, I mean, you'd be on an asteroid, which is really cool, but the other problem would be that you would be covered in gravel.
I mean, it's really tough for the space worms to burrow into all that gravel, doesn't it?
So Carrie Bean has connected me with some people at Lucasfilm to hopefully give a talk there about asteroids, and what do you say? Like, sorry, people 40 years ago had a not good concept of what an asteroid was, and that you could have space worms living on them, but what do you say to that? But yeah, they probably aren't space worms living on that because they would be dead. They would have all their blood coming out of their ears. They would be freeze-dried. They'd be freeze-dried space worms.
Aw, poor space worm. All right, speaking of more planetary objects, Paul, let's talk about 67P, which has had enough to drink and needs to go home.
Yeah, going from spooky, scary asteroids to party comets, because we all know comets are the partiers of the solar systems. So astronomers at the Paris Observatory, or the Observatoire de Paris, looked at Comet Lovejoy, which was just discovered last year, I think. And then earlier this year, it came at its closest approach to the sun, and so the sun heated up, and all this stuff started boiling out of the surface. And they were able to look at all the stuff coming out and figure out what it's made of. And there was lots of water, of course. But then they also discovered things like alcohol and simple sugars and all sorts of complex organic molecules. And that's pretty exciting. So it means that the early solar system, where these comets are leftovers from the early solar system, had all this stuff already kind of built in, and it has interesting implications for the origins of life and the kind of chemical soup that we had available on the Earth when life was first getting started. And it's something like 500, or the analogy they use, of course they're French, so this is their chosen analogy, was 500 bottles of wine per second. That's a very French unit of measure.
I mean, we should note that the universe is basically chock full of alcohol. You look out in gas clouds around other stars and between the galaxies, and you see alcohol everywhere. And so, really, it's surprising how little we have in our solar system relative to what we see everywhere else.
So go home, the entire universe, you're drunk.
Yes, that is highly true.
Yeah.
So it's kind of interesting. I mean, I think one of the interesting things about the alcohol, right, is that astronomers are looking for other places that organic molecules are found around the universe in clouds of gas and dust, and especially in the comets, because we wonder where some of the organic molecules that help form us came from. So does this help with sort of the search for life in the solar system and the universe?
Yeah, it helps us try to figure out what kind of basic elements and compounds are available that life needs to get started, whether you need to cook them up on a planetary surface or whether they kind of come pre-packaged for you. That affects the probability of life appearing anywhere.
Fantastic. All right, Morgan, let's learn about what's happening with Dawn and Ceres.
Yeah, so for the last 7 or 8 months now, we've been tracking Dawn as it orbits about Ceres, the largest asteroid in the asteroid belt. And even though they had a very drawn-out, complicated plan of observations they wanted to make, all the attention has really been focused on one thing, and that's what the heck are those white spots on top or inside of some of the craters that we see.
And
And so two things happened this week. One is they released a new highest resolution image of these spots thus far, and I'll share a picture of that with everybody. And the way they took this picture, oh, no, that's the pumpkin. The way they took this picture is actually by compositing two images together. Because one of the most important things to remember about asteroids, and this kind of plays back into the question of why didn't we see the pumpkin asteroid before this, is that they're extremely dark. Asteroids like Ceres can be as dark or darker than coal. And so when we want to take a picture where we can actually see surface details, we have to change the exposure on our camera to really pump up the brightness. And that tends to completely blow out everything else that isn't coal-colored in the image. And so what they did to make this very high-quality image is take a long exposure to get an image of Ceres, and then take a very quick exposure to get an image of these mysterious white spots. And then we paste those two images together and we get what you can see here. And so what we see is a lot of small patches of this white material spread throughout this crater. But we don't still yet know exactly what it is. And two theories have been advanced. One that we've talked about a lot is that this could be ice condensing on the surface of Ceres within this crater. The other is that this could be salt. And so if you had some reservoir of salty water or salt mixed with ice underneath the surface, and that was to be exposed or to escape out, that water could sublimate away and leave the salt behind. It's just like if you boil a pot of water and you have some salt in it, maybe you're making pasta or something. When all that water's gone, you get that salty residue left in the bottom of your pan. And that could be exactly what we're seeing here. And the way to answer this question is to get closer. And that's a process that started this week. And so for a while now, Dawn's been in its medium mapping orbit. It's about 1,500 kilometers away from Ceres, taking a series of pictures to provide images like the one we were just looking at. But over the next few weeks, the fancy ion drive aboard Dawn will help lower the orbit to about 500 kilometers. And normally this kind of thing would happen pretty quickly, but the ion drive doesn't put out very much a force at any given moment, and so they have to slowly lower their orbit down. And this is going to lower them down into their low altitude mapping orbit. And this is as low as they plan to get, about 500 kilometers over the surface. And so at least for the course of the nominal mission, it should provide the best quality images of these spots that we hope to see. And the mission is slated to last at least through March of next year, which would make one full Earth year at Ceres. And they think that they might have fuel on board sufficient to last through the following December, so a year from next month.
So we're going to get much higher resolution images of what these white spots are, but there's a chance that we still just won't know. We won't get the answer. And so I propose that we find some crew that's got a lander ready to go and retask this lander perhaps to go to Ceres instead, which is going to be way easier than going to Mars. You could volunteer your SpaceIL mission to go and clear up this white spot tree on Ceres?
Maybe the SpaceIL 2.0 mission, but landing on Ceres should be much easier than landing on the moon because of the lower gravity.
It just makes sense on every level. You could land on the moon, win the Lunar X Prize, and then take off again, Ceres, and then
we don't have enough fuel for that. No way.
More seriously, though, I mean, this sort of is highlighting what could be the future of planetary science, which is we have all of these interesting objects out there that we've made observations of from afar, whether that's with Arecibo from Earth, or taking pictures with Hubble from orbit, or sending an orbiter like Dawn or Rosetta. And really, to understand what's happening, we've got to go and land on as many places as possible. And if we can do that for much more cheaply than we've been able to do in the past, then that's really going to expand the opportunities for understanding these objects at a whole different level.
Just
I think
take it under consider it.
I think that the planetary scientists who work on astrobiology will disagree with you.
Yes, I tend to agree. I tend to agree. Now, the cool thing that hasn't come up yet is with this new lower orbit, we're going to be at 35 meters per pixel resolution. And while it may not be sufficient to solve is this ice, is this salt, it will allow us to start to get a deeper understanding of all of the weird geology that we're finding on Ceres, including that really mysterious and not talked about 4-kilometer high mountain.
Is Ceres mappers a thing yet?
It is on the list of things to happen, but the data has to get released to PDS first.
That's really cool. So when will we get our answer, Morgan?
Well, it could come as soon as a few weeks, if by answer we mean better pictures. It also could come never, because as Pamela said, no matter how close we get, if we're not actually there, we might not be able to distinguish these sorts of things.
At a certain level, you want to go pick up a rock and lick it, because really that will tell you if it's salt.
There you go. So SpaceIL, that our future rests with you.
So can we put a tongue
you can get the answer to this question for us. A tongue, yeah.
I accept the challenge.
Yeah, and then it could be the salt, and then it goes. Oh, it's like some kind of tequila thing, or some
we're
kind of a party. It is now a space party,
which is way better than the space.
All right, let's move on. Last but not least, let's talk. We had, of course, Carolyn Porco here on Talk About How'd it go?
We had Carolyn on last week. That was excellent. I think what we lost when your audio cut out was asking how the flyby went. So on October 28th, the Cassini spacecraft flew past Enceladus. This wasn't its closest approach ever, but it was its closest approach to that south pole that we're also interested in. This is the part of the little moon where we have seen vast geysers. And some of these geysers are point light emanations. Some of them are fans emanating from cracks in the surface. All of this, combined with other data, has led us to believe that this moon has a vast under ice ocean, sort of like what we also see on the world Europa. Now, we are just starting to get the image data down from the spacecraft, and you can find that pretty much all over the internet currently. But what we're all eagerly awaiting is, as the spacecraft did its flyby, it collected droplets from the geysers. So as it flew just a few tens of miles above the surface, it collected some of that escaping moisture. And the on-spacecraft analyzers are now looking to see, is there molecular hydrogen in sufficient concentrations to indicate that there is vast subsurface hydrothermal vents. Now, hydrothermal vents are something that we have here on Earth, and they allow life forms to exist deep in the ocean at depths so great that no sunlight ever penetrates. And in fact, there are entire ecosystems that exist purely off of the chemical and heat environment that is driven by these hydrothermal vents. So while Cassini doesn't have anything on board that would allow us to look for microbes in those droplets, it does have the ability to tell us, yes, there's molecular hydrogen, and yes, this indicates that there's active hydrothermal processes deep within that oceans.
Does it have a tongue?
It does not have a tongue, but it does have a mass spectrometer, so it can tell us if there are other interesting chemicals, and we are slowly building up actually a fairly cool chemical map of what comes out of this moon.
It
does.
Yeah, and Enceladus is really becoming one of the most interesting places to look for life in the intersystem, partly because it's clearly got tons and tons of water under the surface, but also just that this water is just made available to space. You literally could just fly through, have a shower through the ice particles and tongue and check to see if there's any bacteria in there. So Cassini doesn't have all the right instruments to do this. It doesn't have that space tongue, as we talked about, but it does, it's going to be able to sort of do the next best thing, is that it has the mass sense of what some of the material is made of. So, you said that it might get at whether there's like hydrothermal activity, but it wouldn't be able to detect any evidence of bacteria, any kind of life.
No, it doesn't have any sensors that would allow it to do that. And in fact, even if it does find that molecular hydrogen, that's pretty much it for this spacecraft. After this flyby, the spacecraft isn't coming back. It has its next 2 years of activities fully planned out, and returning to this world isn't part of that plan. So whatever data we continue to download in the next couple of weeks, that's going to be all we have until we send another mission back to this ringed world.
So what we really need is some kind of lander that's ready to go that could fly away.
Yeah, again, astrobiology would not approve. What we really need, and what makes this the most interesting world to explore, is with Europa, we'd have to land and drill, and that would potentially contaminate its oceans and kill everything there. If we go to Titan, well, we've already landed a spacecraft there, so perhaps we already killed everything, but before we land again, we really do need to think through what we're doing a little bit better. With Enceladus, it has these geysers, cryovolcanism, and because it is spewing its ocean contents out into outer space, helping to constantly refill Saturn's rings, we don't have to land on it. We don't have to touch it in order to get a sample. So what we really need is more spacecraft that can go out and, in the spirit of Stardust and so many other sample missions, gather stuff from outer space and allow us to better understand things that have been willingly given off already.
Right. So Enceladus is sacrificing its precious biosphere out into space. The least we could do is sample it to find out what's in there.
Yes.
All right, Paul. Let's talk about the engine that's been developed.
Yeah, it's not a tractor beam. Do you want me to say more?
Yeah.
Oh, okay. Is
the Death Star's tractor beam?
No. Okay, this is University of Sussex, right? And they're developing this technology that uses sound waves to nudge around tiny objects and kind of levitate them and push them around and move them side to side. It's just like if you're in the ocean at the beach or something, there's water waves that splash over you and move you around. Sound waves are just pressure waves. They're just moving air, and you can use that force of air changing it very carefully using lots and lots of little speakers arranged just right to push stuff around. And right now they're levitating little tiny balls of foam, which is useful, I guess, in the small foam ball moving industries. They've got a long way to go before it has lots of applications. What might be more useful, and thanks, Pamela, for pointing this out in the emails prior to this show. Obviously, this won't work in space because there's a serious lack of air molecules. But what does work is using lasers, and there's these things called optical tweezers, where you use a laser that's more intense in the center of the beam and less intense at the edges, and you can actually control little dielectric materials. As the light passes through the dielectric material, it refracts, and it actually keeps that little bit of material at the focus of the beam. And so if you can pick up your laser, you can move it around, and the little thing goes around with it. It's and by little I mean like nanometer or micron sized, super tiny. Not quite Death Star unless you're a virus or something.
Right, but you could
optical
totally. I was going to say you could take out the nanobot spacecraft if you needed to.
You could
move them around.
You can take out the microscopic
Covered in
line.
styrofoam. Yeah.
So I've actually built optical tweezers because what else are you going to do with your spare time? And the cool thing about optical tweezers is you can use them to move around particles, and they have industrial uses in biomedical engineering where you can use them to expand out DNA strands and a variety of other things. And what is limiting the optical tweezers is you have to have things that the force of light that you're focusing is capable of moving. But as we start to look at technologies like laser sails, big lasers are in our future, which means moving things around using optical tweezers, except I think they're probably going to become more like optical sky cranes, is potentially in our future as well. All you have to do is focus light down to a point from a collimated beam.
All right, so one last story before we wrap this up. Morgan, show us some pictures of another Plutonian moon.
That's right. Since the flyby in mid-July, we've been tracking the release of images of Pluto's moons one after another. Of course, its large moon Charon came first, but we've been adding on its smaller moons since then, and we finally got its last one, Kerberos, released last week, and this is a story we missed last week. So here's a picture of Kerberos in all its pixelated glory, and I mostly like this because, once again, it looks like a duck. And as Pamela said to us before this started, it's a universe of ducks.
I've not seen the duck, to be honest.
If we put this, here's its head, here's its body. This is a duck, like nose-diving, face-planting duck. And if we put it in comparison to all of the other moons of Pluto, you can see that Kerberos is the smallest. And that was surprising. They expected it to be much bigger based on gravitational perturbations within the system. And so now they're kind of puzzling over where their calculations went wrong to suggest a much larger object than what was finally actually observed. And you can see Hydra here on the right, also duck-like.
Little duck-esque, yeah.
Yeah, and of course the quintessential duck, Comet 67P.
And you had a model of 67P there, didn't you?
Yeah, here it is, 3D printed.
And that is so duck-like.
Okay, now I see the duck.
It's duck.
Sandy, as a person who zaps asteroids for a living, what's with all the ducks?
So it's interesting because we think that Yorp, which is Yarkovsky, O'Keefe, Fredachevsky, Paddock, pretty much its sunlight causes asteroids to change how they spin, and it can sort of change how their shape, and it can cause formation of these sort of contact binary shapes that we see in the asteroid population. But comets don't necessarily spend as much time close to the sun, so what's going on there? Jordan Steckloff, who will be at DPS, and maybe we can get him on the Weekly Space Hangout, he talks about how you have sublimation from comets that would affect your spins, and that can cause two bodies to sort of stick together at weird angles and get things like Churyumov, Gerashmenko. But who knows what's going on with the moons of Pluto? Those things would definitely be dominated by the strength regime and the gravity regime, so we get changed shapes.
I'm totally losing Sandy again. You're totally yeah, something's disconnecting on you.
Is that better?
No.
Please turn back the Cylon fleet, Sandy. We don't want any part of this.
Darn. There are flies on my line.
That's what it sounds like. It flies. Yeah. Unfortunately, we're going to have to. Yeah, it's garbled. It's totally.
Okay. Blame whoever.
Yeah, it's like you're talking through a wormhole.
Let me try.
Try jiggling a cord. Yeah.
Poor Sandy.
Oh.
We think contact
Technology.
binaries are probably pretty common out there in the asteroid belt, and if you had a smaller thing and a larger thing, and you pushed them together, and those things weren't round, you might very well get a duck shape.
Is that better? Can you hear it? No one can hear
Yes.
it.
Yes.
No, we can hear you. You
Yep,
sound much better.
it's perfect. All right. Well, on that note, let's wrap things up. So
Okay.
let's give everyone a chance. But whatever you did, Sandy, in the future, do that again.
Is this working?
Yeah.
Yeah, it sounds great. So, Sandy, where do people find out more?
I'm on Twitter as Sandy. But yeah, anyway, comets are weird. Small moons are weird. Science.
Morgan, where do we find out more?
On Twitter at Morgan Rehnberg and over at my website morganrehnberg.com.
Pamela, where do we find out more?
You can follow all of my scientific endeavors over at cosmoquest.org, and I tweet as @StarStrider, and my personal essays on life in academia are at starstrider.com.
Paul.
You can follow me on Twitter and Facebook at Paul Matt Sutter. Matt is my middle name, so it goes between the Paul and the Sutter. You can go to my website, pmsutter.com. If you really love the sound of my voice and want to listen to it for like a half hour to hour straight, you can go to my podcast, askaspaceman.com. And if you really like that, you can throw some pocket change toward me at my Patreon campaign, patreon.com/pmsutter. That's so I can pay for actual professionals to help me with the audio and video editing.
I'm glad you were willing to just volunteer that information without me having to drag it out of you. So good job, Paul.
Next time we'll have the dialogue. Don't worry.
Yeah, that'll be good. And Yoav, thank you so much for joining us this week. And once again, where do people find out more about your team and the Google Lunar X Prize?
Okay, we have a site. We are called SpaceIL, in one word. You can see me in Twitter. I tweet as Massacreated, which is the name of my blog. I tweet in English, but my blog is in April, so that's
awesome.
it. I also have a hangout, a show of my own, which is inspired by the Weekly Space Hangout.
Where do people find it? Is that linked from your website?
It's called the spaceship in Hebrew, Hachalalit. So if there are any Hebrew speakers in the audience, in the viewers, so
probably half.
Half of them.
Half of them, yeah. So once again, I'm
Hey, Fraser, do you have anything going on this afternoon?
Yeah, I do. I'm going to go get married this afternoon. So literally, as soon as this episode is over, I'm going to go and get married to my girlfriend here in town. So yay! Yeah. I guess it's only fair. So thank you, everybody. A big thanks as well to the Weekly Space Hangout crew who coordinated our guest, Yoav, who was part of the crew, coordinated himself. Anyway, it happened. Thank you so much. As well as suggesting all of the stories that we talked about this week. So actually, about half of the stories that we talked about this week were proposed by the Weekly Space Hangout crew and then voted by the Weekly Space Hangout crew. So you can be a part of this. There's instructions at the Weekly Space Hangout crew Google Plus community. Just go to bit.ly/WSH crew, and you can get a link there, and then you can join the crew and find out how to propose stories and vote for stories. So yeah, and you can see me, F. Cain, and next week I'll be a married man. All right. We'll see you guys all later. Thank you so much. We'll talk to you all next week.
See ya.